Ya, Assalamualaikum dan salam sejahtera. So we continue our lecture on ideal flow. So in this lecture, I would like to introduce you with basic patterns of flow. Okay. So what is basic pattern of flow? So it is consists of four patterns, which is linear, source, sink, and vortex. So why this basic pattern is actually very important in ideal flow? Because in ideal flow, at the end of this topic, we will predict the streamline. So means that we have one object here. So we need to predict so what kind of streamline occur for certain basic situation. So this is our purpose in this topic. Okay, however, before we learn about this, I need you to imagine that, okay, uh, uh, flow is actually a complex motion. Okay, so, but it is very, very difficult for us to describe complex movement. Uh, that means that to simplify that assumption, so we need to start with the basic one. Okay, so because the idea is, for example, let's say we have a coordinate like this one, and then we have uh, a square box like this one. So, and then finally, we need to move this square box into this location, but the shape is now changed into this one. Okay. So in this situation, as I said, it is not easy for us to write a mathematical expression to express this situation into this situation at one time. Okay, but what we could do is we express the mathematical equation for each step of deformation. So means that maybe we could assume that we could express a mathematical transformation for this square box from this location to this location. So it is simple because we only change the x value parameter. Okay, so we remain all the parameters exclude instead of x. So and then we could think about the transformation from the x to the y location, but still the shape is not sheared. Okay, we still maintain the shape, and then we only change the location of y, and then at this location we change into this box, the square box, into the shared shared shape. Okay, so means that we use three basic transformation to express the deformation from here to here. Okay, that's why we need to know what is the basic patterns of flow that we need to do before we could combine them to reflect or to represent a complex situation. Okay, that is the purpose of this basic flow. So we have four basic flow, so which is linear, source, sink, and vortex. Okay, so there are, as I said, for basic patterns of flow, so we have four of them as listed here. And for linear flow here, in some textbook, it is also called a uniform flow. So uniform and linear is actually telling the same things. And then we have source, sink, and vortex. Now we are evaluating the linear or uniform flow. Okay, please imagine that we have a molecule here, and now it's transformed from this location into this location. Okay, so the velocity for this resultant movement, okay, can be expressed as q. And then the velocity component, for this one, we could express as u as shown in this figure, and also the v. Say this is u and this is v. So again, because we could express this with velocity, so and then we know that velocity has the relationship with psi, so we know that v is equal to psi over. So and then we assume that the a is actually constant. So because we are evaluating the same things, so and then we could neglect the value of a at this moment. So means that we could say that a psi for linear, a resultant for flow rate here is actually the summation of psi for x direction plus the psi in y direction. So y, okay, for calculation of psi, okay, for calculation of psi here, we need to use a plus. Okay, it is not psi linear square equals psi x square plus psi y square. So we cannot use this. Okay, the reason is psi is a flow rate, and flow rate is not a vector. Okay, velocity, yes. You need to understand that q square it is equal to u square plus v square. Why we use that equation? Because velocity is a vector. But psi, so I told you before, psi is linear. It's no, I'm sorry. Psi is flow rate, so it is a scalar. So for scalar, we just need to add the magnitude only. So and then same idea of this one is actually learned by you in fluid mechanics 1. So you know that if you have two pipes like this, so we have one flow rate here, Q1, and another one is Q2 here. So what is the total of flow rate here? So you just add Q1 plus Q2. So same like this. So we have the total flow rate here. So it means that the total flow rate here must be the summation of y psi x and psi y. So this is the idea of stream function, because it must reflect the idea of flow rate. Okay, so then first idea you should know is psi is actually the idea of flow rate. So you need to do the process by the idea of flow rate. So if we have a combination here, means the resultant, the total of the flow rate from point 1 to point 2. So it also can be calculated by adding the flow rate in x-axis with the flow rate at what on y-axis. So we could write as psi x plus psi y, and then let's say we simplified the word psi linear here with psi with subscript l. So we have psi l here is equal psi x plus psi y, and then psi x here can be written as uy. Okay, it is just imagine that we have a psi x here. So and then we have a cross sectional here. Let's say we have a box of this one. So and then psi here is actually the velocity of u, because we are evaluating an x-axis. So u here, and we need to multiply with the cross-sectional area here. So the cross-sectional area here, the thickness of this one is dy. And then we assume that the width here, okay, is equal to 1. So now psi x is equal to u times dy. So let's say we just to simplify the mathematical expression, so we do not use the idea of dy. Let's say we have it is y. So means that psi x here is equal to u times y. Okay, if you want to use dy, you must use d psi x equal u dy. Okay. So and then for psi y here, so I think you could imagine the same things. So you just imagine that we have a box here. So and then the velocity is v. So this is the cross sectional. So mean that the psi y is equal to v times dx. Okay. Okay, and then we simplify the d here. So we have psi y is equal v and x. So and then again you must agree that this direction is actually could create a counterclockwise direction. So we put a negative sign here. So and then we could say that the linear or the uniform flow stream function for linear or uniform flow can be written as this one. So means psi linear is equal to uy minus vx. So and then if you want to substitute or if you want to show this equation in polar coordinate, you may write like this. Psi linear is equal to ur sine theta minus vr cos theta. So from where we get r sine theta and r cos theta, as I said previously, so if we have a circular like this, so the center point of this circle is actually the origin of Cartesian coordinate. So this is an r here. So you could imagine that this is, if you have theta here, so this is x and this is y. So the relationship between r, x, y, and theta can be written like this one. So I think you already have idea to about this one. Okay, so this is the basic stream function that you should know: linear or uniform flow. So it is equal psi linear, it is equal to uy minus vx, or ur sine theta minus vr cos theta. Okay, so however, in some textbooks, means in many textbooks, they will simplify the psi linear is equal to ur sine theta or ux. Okay, or uy. Okay, like this. Why it simplify like this? Why we always neglect the value of v here? Because it is depend on the way we see the motion, we see the movement. Okay, katakan kita ada satu molekul bergerak daripada sini ke atas. Okay. Okay, sebelum tu pertama sekali saya harap awak faham apa yang dimaksudkan dengan linear. Linear ialah maksud pergerakan dalam garis lurus. Walau bagaimanapun di dalam skala yang besar, sekira molekul awak bergerak seperti ini, walaupun ia tidak bergerak di dalam garis lurus, okay, tetapi kita masih lagi mengatakan bahawa pergerakan molekul ini adalah linear. Kerana apa? Kerana had laju ataupun pergerakan molekul ini boleh digambarkan dalam bentuk meter per second. Itu sebab had laju U mempunyai unit meter per second, kita katakan dia sebagai had laju linear. Okay, sekiranya kita ada katakan omega, kita ada radian per second, so unit dia bukan meter per second, so kita tak panggil radian sebagai had laju linear. So kita akan panggil dia sebagai had laju putaran kerana dia menggunakan unit putaran sebagai simbol ataupun unit di dalam ukuran had laju tersebut. Okay, walaupun dalam keadaan dia berjalan bengkang-bengkok, tapi selalunya kita masih lagi mengatakan linear velocity kerana had laju yang ditunjukkan di sini masih lagi dalam meter per second. Maknanya kita boleh seolah-olah menunjukkan berapakah jarak yang dilalui oleh molekul tersebut bagi setiap masa yang bertambah. Okey, itu dapat. Itu satu yang awak kena faham tentang linear velocity. And then kita nak membincangkan mengapa di dalam setengah buku kita abaikan nilai VR cos theta. Oleh itu, rumus psi untuk linear ataupun stream function untuk linear flow akan menjadi uy atau ur sin theta. Okay, ini perlu awak hafal. Okay. So, Alasannya adalah seperti ini. So, kita anggap bahawa kita ada molekul di sini bergerak pada arah dengan certain angle di sini. Okay, dengan certain angle. Okay, dan berakhir di sini. Dan pergerakannya adalah dalam garis lurus. Oleh itu, kita boleh mentakrifkan pergerakannya adalah pergerakan dalam bentuk linear. Kemudian kita kata, kita perlu ingat di dalam ideal flow ialah salah satu elemen yang penting di dalam ideal flow ialah penentuan koordinat. So maknanya awak yang tentukan koordinat apa yang awak nak guna, sama ada koordinat Cartesian koordinat ataupun polar koordinat. Dan penentuan koordinat ini actually it depend totally on you. So for example, kalau kita ada pergerakan daripada sini ke sini, and then you imagine you put this movement into Cartesian coordinate like this one. So this is X and this is Y. So means you need to use this equation, all of this equation. Because in this motion, in this movement, okay, this component has U and also V and it still have U and V here. So we have theta here. So means that we need to fulfill the value of this one. U1 minus Vx or UR sin theta minus VR sin theta. VR cos theta. Okay. Okay, this is the what we have here. However, if we have movement from here to here, and then I would like to set the coordinate here, the Cartesian coordinate like this one. So means saya nak ubah sedikit, saya nak plotkan pergerakan itu atau saya nak letakkan pergerakan itu di dalam koordinat tetapi dia berbentuk seperti ini. So ini adalah X dan ini adalah Y. Oleh itu, di dalam pengiraan ini kita dapati bahawa molekul ini hanya mempunyai komponen velocity of X. So means that the velocity here is always U. Tidak akan ada V kerana tidak ada perubahan in term of Y coordinate. So dalam keadaan ini, kita boleh ringkaskan lagi psi untuk pergerakan ini sebagai ini. UR sin theta. Kerana apa? Kerana kita telah relocate ataupun kita meletakkan koordinat yang membantu pengiraan kita dan ia akan menghilangkan value of V di sini. Okay, tetapi secara generalnya, linear velocity actually is this term. So Vy minus Vx. So kita kena tunjukkan juga apa nama tu pengaruh V dan pengaruh U. Okay, sampai sini okey ke? Boleh faham ke?
Boleh dah.
Okay, so saya harap awak dapat faham, awak dapat imagine why after this we will only assume that psi linear is equal to Uy or Ur sin theta. Okay, so you need to remember this term. So it will help you to calculate faster. Okay, awak kena ingat yang ini. Ini adalah four basic flow pattern. Okay, so means that if we calculate the phi here, so again we could use the same idea. So means that if we have a Cartesian coordinate here, so we have these two molecules, so we could assume that we have a phi here and phi here, phi for X and this is phi for Y. So and then we could have this kind of equation, and finally we could write the phi linear is UR cos theta. And I hope you understand how we get the value of UR cos theta, because we are arranging the coordinate like this one. So we have phi as UR cos theta. Okay, now we would like to explain to you about the source. Okay, source ni sebenarnya ialah You just imagine that you have one source, satu sumber. Let's say you have one source of water here, and you just imagine that you have a sink here, and you have a hole at the center. So, and then you connect this one with a pipe hose, okay, pipe with water, and the water will comes here, and then it will flow into this bowl, for example, into this container. So you just imagine there are no resistance and so on and so forth. So in ideal, you must know about the ideal flow here is the calculation or your understanding about the water flow in ideal condition, in a very means in a condition without any friction. So you just imagine dia adalah satu aliran secara ideal, secara imajinasi. Awak boleh imagine bahawa sekiranya kita ada satu sumber air di tengah ini, so air akan bergerak pada arah jejari dengan had laju yang sama. So means that the water will flow in radial direction with same velocity. Because the friction is zero, so means that all water will flow at the same velocity. So this velocity, okay, this velocity is show the radial axis. So we state this velocity as UR. So and then in this situation, you must know that the water that comes into this source must have flow rate. Okay, but in this topic, we don't call it as flow rate. So we call it as strength of source. So jadi for these sentences, source flow has a strength called strength of source, and its symbol is M. Okay. Maksudnya ialah as stated here, the strength of a source is the total volume flow rate or flow from it. Okay, so nampak So maknanya idenya ialah sekiranya kita ada satu lubang di sini, dan lubang ini disambungkan dengan lubang air. Air boleh masuk dan keluar di sini, tetapi air ini akan keluar dengan certain flow rate, kadar alih. So kadar alih inilah yang dikatakan sebagai strength of source. Okay, kerana kalau kita tidak ada kadar alih, so macam mana air ingin mengalir. Okay, yang ini saya harap awak dapat faham the meaning of M here and what is the meaning of strength of source. So it is actually reflected the volume flow rate. Okay. I hope you could read again in your textbook, Porter textbooks, because in Porter's textbooks, sometimes it use different symbol, but it is okay. If you could understand my lecture notes here, you could understand what Porter tried to tell you. Maybe the symbol is different, but it carries the same meaning. So awak fahamkan dulu apa yang saya ajar, then awak try baca nota Porter. Mungkin ada beberapa simbol yang agak berubah. Okay. Dan simbol ini sebenarnya berubah mengikut buku teks. Okay, cuma saya khawatir nota yang saya buat ini mungkin tak sama dengan buku Porter. So saya harap awak dapat sekali lagi. Walau bagaimanapun sekiranya menjawab exam, awak kekal dengan menggunakan teori saya, insya-Allah jawapan masih lagi sama, tidak ada perubahan. Okay, so sekarang ni what we need to do is we need to calculate what is the value of psi for source. So jadi apa yang kita buat ialah kita mengira kita perlu mengira stream function atau psi untuk source. Jadi apa yang kita ada di sini ialah ada lagi sini. Okay. So apa yang kita ada di sini ialah first, from our diagram we have the value of UR. So UR here is the velocity on the radial axis. So because we know the source has its own strength, so strength here means its own flow rate. So we could determine, or we could build an equation, derive an equation which is volume flow rate divided by the area perpendicular to velocity. So this equation is actually reflected the flow rate. So you have Q is equal AV. So and then you could say that V is actually Q divided by A. So Q here is the strength. So we have an M here. So and then the area here is equal to 2 pi r. So here, please be careful because you need to really understand how to calculate the flow rate. That's why you need to understand that Q is equal to AV and A here is a perpendicular area with the velocity. So the velocity is here. So what is the perpendicular area? So this is the perpendicular area. So means because we know that it's come from one source and ideally, so mean if the friction not influence the movement, so the water will flow, will expand in a circle area like this one. So means that you need to take the parameter of this area as your cross-sectional area. Okay, just imagine that air kalau mengalir keluar, so dia akan ada thickness kan. Okay, air akan keluar di sini, dia akan ada thickness. So cross-sectional area Baira adalah thickness ini. So jadi apa yang perlu awak buat, awak perlu cari circumference. Perimeter ini didarabkan dengan ketinggian air. So selalunya kita beranggapan bahawa ketinggian air yang ini adalah 1 unit kerana kita hanya mengira dalam bentuk dua dimensi. So kita ada X, Y ataupun dua paksi di sini. So jadi yang ketebalan ini kita akan anggap sama dengan 1 unit. So jadi bagaimana untuk kita mengira A? So kita kena mengira perimeter dan didarabkan dengan ketinggian ini. So kita boleh dapat luas kawasan air keluar. So yang ini saya harap awak dapat imagine. Kerana di dalam pengiraan ini, sekiranya pelajar diminta untuk derive balik equation ini, kebanyakan pelajar akan ambil area bulatan. Dia akan guna area adalah pi r square. So saya tak tahu kenapa pelajar agak terkeliru dan gagal untuk mengenal pasti a suitable area to be used in flow rate calculation. So this is a very, very basic fundamental idea that you should know. Okay. So jadi kita mengetahui bahawa UR adalah velocity yang kita dapat daripada soalan. Oleh itu kita boleh menulis UR sama dengan strength of source divided by its area. So it is M over 2 pi R. And we know from the Cauchy-Riemann equation UR is equal to d psi over R d theta. Okay. So and then we assume that U theta, which is the negative d psi over dr, must be equal to 0. Why it is equal to 0? Because there are no velocity rotates the circle area. So yang ini saya rasa awak boleh faham bahawa molekul di sini kita kata hanya akan bergerak ke hadapan. Dan tidak ada molekul yang bergerak pada paksi theta. Kerana kalau ada molekul yang bergerak pada paksi theta, tentulah aliran ini akan berjalan bengkok seperti ini. Kerana kita ada dua velocity yang bertindak. Satu pada arah R dan satu adalah pada arah theta. So oleh kerana had laju adalah straight sahaja macam ini, tegak. Oleh itu kita beranggapan bahawa had laju pada arah theta tidak wujud. So saya harap awak dapat imagine tentang ketidakwujudan had laju pada arah theta. Okay, so this is the idea that you should know that now we are trying to use this equation to get the value of psi. So how to get this one? So we could start our calculation like this one. Okay, we could start our calculation like this one. Okay, let's say we have d psi over r d theta is now equal to m over 2 pi r. So and then we bring the r d theta to the right hand side here. So and then after we simplify the value, we cancel the value of r here, and then we integrate both sides. Okay, because we don't have any terms of theta here, so means that we are integrating 1 times d theta. So 1 times d theta. So the integration of d psi will give us psi. Ini adalah integrate dan differentiate. So maknanya kita kamirkan sebuah pembezaan, so kita akan dapat dirinya sendiri. So maknanya integration of differential term, so you will get its own term. So maknanya kita akan dapat psi juga. And then the integration of 1 d theta, so we will get theta. So means that from this simple integration process, integration work, we could say that the stream function, the psi for source, it is equal to m theta over 2 pi. So which is m here is the strength or the flow rate, the strength of the source. The theta is actually the angle that because we have here we could have an angle here, so this angle need to be take into account. So and then we have a 2 pi, so it is reflect the total area of circular shape. So that is the idea. So I hope you could remember. Now you know the psi for linear, and now we have the psi for source here. Okay, so this is the calculation for the phi. So we know the value of UR, and then we could write UR is equal to m over 2 pi r. So, and then because we want to calculate the value of velocity potential, so we use Cauchy-Riemann equation. So we know that UR is d phi dr. So now we integrate this one. So we have d phi dr equal m over dr. So and then we could get phi here is equal to m over 2 pi ln r. Okay, you may try this at home. Okay, so the idea is the simple one. So we based on what we have in reality, what we get from the diagram first, and then we try to equalize with any equation from Cauchy-Riemann equation. Okay, next, we are evaluating sink. Okay, so what is sink? So sink is actually a reverse flow of source. So if source, we have one source here, and then water will flow forward outside the source like this one. And for sink, we have the reverse direction. So mean for sink, you just imagine that you have a sink in your at your home. So you have a water tap here, and then if you pull the stopper here, so you will find that all the water will flow into one hole. So because we are evaluating only one simple motion, so we just assume that there is only UR, means velocity parallel or velocity on the radial axis act on this situation. Still U theta is not exist. So we assume that U theta is equal to 0. Okay, so this is the difference between sink and source. So again, flow for this situation also has a flow rate, but we call it as a strength of sink. So we still use the symbol of M. So and then if we calculate, so I just shortcut it here, I just to make it simple, because the calculation is actually exactly the same with the previous notes with the source, but you need to put a negative sign in your UR, because normally when your UR is expanding from the radial side, so it will give you a positive value. So if the velocity is towards the this center of source, the center point, so the velocity is negative. So you just duplicate the calculation on the previous notes on source. So you will find that psi for sine is negative m theta over 2 pi. So and then if you calculate you try to calculate the value of phi for sine, so you will get it is negative m over 2 pi ln r. So it still carry the same terms, but the difference is the existence of negative. So this is the stream function for sine. So and then I would like to show here about vortex. Okay, because we right now we don't have any analysis or any representative for u theta. In linear, for sure there are no u theta because the motion is in straight line. In source and also in sine, okay, we assume only the movement is only on radial axis, so means it still do not have any u theta. So now in the fourth example here, so we evaluate, we imagine that there is one motion which is only has v theta. So if one motion here has only one velocity, so and that velocity is a u theta, so means that it will rotate like this one. So it keep rotate like this one, and it keep maintaining the value of r here. Okay. Okay. So and then okay. So because the motion here, the nature is rotate like this one, so we are using the idea of circulation, gamma. So what is the basic idea of gamma? So gamma is velocity times the distance traveled by the molecule. So means we have a molecule here and we need to multiply the velocity of this molecule with the total distance traveled by this molecule. So means that in this situation, we assume that the velocity is u theta. That's why we use u theta here. And then the distance traveled by the molecule is actually the circumference. So it is equal to 2 pi r. So and then we have a u theta here. So and then gamma over 2 pi r. So we just bring the 2 pi r to the left hand side. So according to Cauchy-Riemann equation, it is equal to negative d psi over dr. So and then what we could do here is we could integrate both sides. But before that, you need to bring the dr here to the left hand side. So you have this term. So you integrate both sides, so you will have psi on your right, on your left, and finally you will get negative gamma over 2 pi ln r. And please remember, when you integrate this one, you will get c. Okay. So for previous calculation, it is okay for you to assume the value of c is equal to 0. However, for vortex, you need to imagine, you need to calculate what is the value of c. So I will explain for you later. Okay, just bear in mind, just remember that for calculation in vortex, you need to calculate what is the value of c. For other calculation, you just assume that if you calculate, the value of c will become 0. Okay. Okay, now we need to determine what is the value of c. So another point here is, it is okay for you not to take any positive or negative sign for the velocity. Why? As I explained previously, gamma or circulation. So we have another term. After circulation, we learn about vorticity, and it lead us to velocity potential. And velocity potential is actually the imaginary line. That's why the negative positive is actually not uh, can be neglected in this calculation. However, in certain textbook, so they will put negative in u theta here. So it's based on the one. So it is okay. So it's depend on you. So both method will give you same answer actually. Okay. So but in this notes in my lecture now, so I use the u theta is not come with a negative sign. So because some students it says that okay, this direction is actually negative, is counterclockwise, so we give a negative u theta here, but it is okay not to put a negative here. Okay, I made mistake. I forgot to neglect to erase this symbol. Okay, so and then so now we need to do the calculation to find what is the value of C. So what we could do is we need to use the idea of boundary condition. So what is our boundary condition actually in this situation? So let's say we have a circular motion of a one molecule like this one. Let's say we have one and this is the center point, let's say. So and then, so the molecule is, okay, let's say the distance from the center point here to this molecule is actually R, and we assume that it is equal to A. Okay, so means that the radius is now A. So and then normally we could imagine that the value of psi here, okay, we will learn about how to determine the value of psi. Okay, but it is okay at this moment. You just uh, assume that the value of psi is equal to 0. Okay, so and then we take this condition. If psi equal to 0 and the radius is equal to A, so we substitute into the equation. So what equation? So this equation. So we substitute, so we get psi is 0, and then ln R will become ln A here. So and then we could get the value of C here is gamma over 2 pi ln A. And then we substitute the value of C into our equation here. So, and then we could get the value as negative gamma over 2 pi ln R plus gamma over 2 pi ln R. And finally, we could write like this, and we could simplify as this term. Okay, so means that as official answer, the psi, the stream function for vortex must be written as negative gamma over 2 pi R over A. So you must remember that for vortex, we must have R over A. Why? Because we have a vortex here. Okay, we have a circular motion here. So we have a vortex, and this is the center point. To make sure that this molecule is rotate with only, untuk memastikan bahawa molekul ini hanya bergerak dalam bulatan dan hanya mempunyai u theta. Awak kena imagine, kalau dia ada dua velocity means dia akan keluar atau dia akan masuk. Awak kena imagine, awak ada dua velocity, so dia akan create another velocity which is resultant velocity. So kalau tak nak bergerak ke mana-mana, so means that dia mesti ada satu velocity sahaja. Oleh itu, untuk dia menjadi satu velocity sahaja, parameter lain yang kita kena jaga ialah we must maintain the distance from its center point here. So makna awak jaga nilai R itu supaya nilai U theta akan sentiasa constant. So oleh sebab Oleh sebab nilai R di sini perlu diambil kira atau perlu kita jaga supaya memastikan U theta di sini tidak berubah. Maknanya tidak ada pengurangan U theta yang boleh menghasilkan UR. Okey. So jadi itu sebab di dalam equation ini kita perlu memasukkan nilai R. Oleh itu di dalam keadaan ini nilai R sama dengan A. Oleh itu kita wujudkan nilai A di dalam equation. So itu sebab di dalam pengiraan vortex awak mesti berhati-hati, awak mesti ingat bahawa di dalam pengiraan vortex mesti ada nilai A. Okay, so setengah buku dia akan menggunakan capital R will be equal to A. So dia akan cakap small r is equal to capital R. Okay. Ada setengah buku dia guna small r is equal to A. So maknanya di dalam soalan nanti, test 1, test 2 dan final, awak kena berhati-hati sebab kemungkinan kami akan memberi tricks di dalam idea ini. Kerana kami ingin pastikan bahawa awak faham nilai A di situ bukanlah cross-sectional area. Okay, ada setengah pelajar nilai A ni nanti dia akan masukkan nilai bulatan tu. Dia kira bulat pi r square. Ataupun dia kira yang macam source tadi, okay, dia akan kira ketinggian ini 2 pi r darab thickness. So awak kena berhati-hati bahawa the value of A here is actually reflecting the radius in vortex motion. So dan seterusnya kita mengira nilai phi. Oleh itu kita dah daripada pengiraan di atas we could say that U theta is equal gamma over 2 pi r, and then from Cauchy-Riemann equation we could equalize with this term, and if we integrate both sides, so finally we could have phi or velocity potential for vortex is equal to gamma theta over 2 pi. Okay, so finally, so this is the conclusion of this one. So I hope you could remember all of this. So if you cannot, the best one is you could draw a diagram and then you could derive your own stream function and velocity potential. If not, please remember this very well. If possible, please remember the phi and also the psi. So if you still cannot remember that, at least please remember these 4 value, because it will make your calculation become easier. You don't need to start to derive your own diagram and to make sure what is source, what is seeing, and so on and so forth.